I guess I can start, I guess. Hi. I think I can start. So today we are trying to cover topic 6. If I have time, we'll cover some of the topic 7. And you can see these 2 chapters are not very long. And so let's see what do we have here. Okay. So the 6th topic is about public good and externality. And the idea is that in the case of buyer and seller, right, when you buy and sell stuff, usually it's within 2 transacted parties. But very often, what the buyer and seller try to do will actually affect other people. And in general, this is called externality. And the special case we focus on is public good, and public good is a special case of externality. Okay. So the classical way to study public good is we want to see what would be the efficient in this case, how the government or a planner should do, which we'll call the Samuelson rule, which is not complicated. The idea is just, in general, when we say optimal, right, the market is like the marginal cost and marginal benefit the same, right? It's like you keep doing something until the cost and benefit equalize, right? And when it's public good, which means that the good is able to consume by other people at the same time, right? Example like national defense, right? Means you consume doesn't affect my consumption, right? Or the sunshine, right? Or nice weather, right? So the problem of provision is like the sum of the benefit of everyone, okay? So that is a famous rule, okay? And as we will argue that this efficient production or provision is problem of prisoner dilemma. No one wants to pay for that, okay? So that requires what we call the undergraduate, you learn the Pigouvian tax or subsidy, which to try to correct the externality, okay? And besides the public one, we have some private provision, right? So like the subway, the highway, these are public good. But I mean, in many places, for example, in China, highway is built by a private company, right? And then you ask, why is it efficient, right? It's efficient because you can exclude people. Later we'll see. And also we see the rise of NGO and charity. That is also a way to solve this kind of under-provision problem. And we're in B school, right? So often the time now these days we care about the corporate social responsibility or the ESG. These are the way to solve the problem. And at the end, we'll focus on one very important aspect of public good is what we call the dealers, okay, in the stock market, or the agent, right, who is going to be the liquidity provider. Okay, he's trying to serve the buy side and the sell side. In doing so, he takes some risks, but by doing that, then he is facilitating the trade of the market. And in order to make sure that he didn't suffer from adverse selection, okay, this public good has an adverse selection problem, and he has to set bid-ask spread. Okay? So at the end, we will try to explain the bid-ask spread is the adverse selection and public good provision problem. Okay, so that is the objective we are doing, okay, for this part. So let's define what is public good. This is the most pure version is a man's consumption don't affect other man's consumption. Okay, and example is national defense. right? Say the government try to buy an air bomber, try to build a nuclear bomb, right? I mean, it protects 1 million people, and 1,000,001 people doesn't change. Okay, no matter how many people, the same. Okay, so the same thing. Okay, clean air also the same, right? You consume the clean air, doesn't affect other people consume clean air. Another example is fireworks, right? And the fireworks that's in the Victoria Harbour, right? That says you consume it, you watch it, you're happy, then it doesn't affect the other people, right? Park are the same, right? You consume the park until it's very congested, right? Before the congestion happen, right? Park is free, right? You there, he's there, right? Until the point that where it's so congested, there's a problem. But before congestion, that's a public good, right? And R&D the same, right? And I do my R&D, and I discover something new, right? Everyone can use it, right? So that is free for everyone. So R&D has this favor, okay? And so how do you usually, or how do economists usually describe this is, how to distinguish it? This is this very simple model to distinguish what is private good or public good. Okay? Consider the case that capital X represent how many goods that can be provided, okay? And small x subscript I, the superscript I is people I could consume X, okay? And that N agent, okay? Public good means that everyone can consume as long as can take the part as long as less than capital X, okay? And private good means that everyone can take its part. Some of its part cannot be more than the total, okay? You can imagine this is how many, say, cans of soft drink, right? If I consume one, then you can't consume the same thing, right? But if the X is the clean air, right? I breathe and the same, right? Or the sunshine, right? There's no distinction, right? You consume doesn't affect my consumption. Okay? This is the usual graph, right? When you learn topic 1, right? X is total number of goods, right? If give to all, guy number 1 will be this this point here. If you give to guy number 2, will be there, right? So this triangle will be, or the line, right, is the thing that you can allocate, right? That's only possible in technology, right? But if you public good, this is the red, having the red square is feasible, right? Because my consumption doesn't affect your consumption there. So that is how to graphically we tell public good, right? By the way, information is public good, right? I know this company worth this much, right? I consume this, I tell you, doesn't affect everyone. But of course, there's subsequent action that I can affect other people, right? If Warren Buffett tell me this particular stock worth this much, right? It doesn't affect him, right? As long as the market doesn't change, right? If market changes, that's a different thing, right? But telling me doesn't change, right? Unless I do something else, right? But there are many things that are public good, right? Your consumption doesn't affect the others. But there will be subsequent things that can affect, but that's the main problem. So as we don't do the proof, but that it will be what we call the Samuelson condition is, I think in the 50s, he wrote a paper and so that if you try to, as a planner or the government, okay, try to look at until when you stop your production is you have to add up everyone's marginal cost, marginal benefit, right? So let's see the graph will be the easiest, okay? This is the marginal cost, the red one, the MC, right? If this well only consists of one guy, so suppose this is MB1, there's only one guy there, right? His marginal benefit or public good is actually decreasing, right? Because the more, there is less, right? The marginal. Then if there's only this guy in the world, then this will be efficient production, right? Because he's the one who would get the good, right? The public good, right? So that would be the efficient production here, right? Produced at this point where the marginal benefit equal to marginal cost, right? But now it's public good, right? That means that the benefit have to be vertically add, right? Because everyone can consume. If you produce here, right? Guy number one will want to pay for this one. Guy number two pay for this one. Right? So the overall benefit to society is the solid line, right? So basically, you just add up everyone, right? And then add together, right? So this called the Samuelson condition is, as a society, as a planner, how you consider what is optimal provision or efficient provision of the public good is to have to add up everyone in society, how much they want to pay against the marginal cost, okay? So that explains why our government spent $10 billion over the past 3 years for national security, right? Because we have 6 million people in Hong Kong. So add up, even though everyone would worth $1 for national security, the add up is a lot, right? And our chief executive said, oh, the national security is very important. Why? Because you have 1.4 billion in China, right? So we spend like 10 billion, right? And how much we spend, right? $10 billion, right? So we just $1 per person in whole China, nothing, right? So that explains why we often said one thing, right? No matter how big the problem is, if you divide it by 1.4 billion, that's nothing. Public good argument, right? Because the marginal cost is shared by everyone, right? You divide it by 1.4 billion, it's nothing, right? And then we said, no matter how small is the benefit, multiplied by 1.4 billion is huge. The idea is here, okay? This provides an explanation why all the government in the world, they spend a lot of money on public good, right? In the US, right, you see how much they spend on the national defense, right? And because of this, right, the marginal benefit is a lot, right? And some of you would ask, okay, in the old days when US sent the astronaut to land on the moon, right? How much they spend the GDP, right? About a quarter of the GDP. Try to spend it on sending people to the moon. And you may ask why? Externality, right? At that time, it's the US versus Soviet Union, right? But US has externality to this Western Europe as well. So that's why they take this into account, because they say at that time it's the capitalists versus the communists, right? So that's why they spend so much money on winning something irrelevant, right? I mean, send the thing to the moon has no immediate benefit to the competition, right? Why don't they just build a few more nuclear bombs, more efficient, right? But there's a externality, public good aspect to that, okay? So I hope that answered you the question, right? And that's why recently I think everyone would notice is something with the public good is the plastic bag, right? And it's the same idea, right? Public good, right? But it's just, you can imagine is you take the plastic bag, right? Right? And everyone is annoyed by doing this, right? And why those activists still very adamant, very strong at saying we should have more plastic bags, right? Even though it's not biodegradable, right? I mean, they want to have more of that, right? But they would argue that, right, because of the marginal benefit, right? They would argue that, okay, for us, right, like this, right? Why we need that, right? They would argue that no. You don't look at our generation. You look at the future generation, and future generation add up is huge, okay? So to see something you didn't see, right? So look at many generations ahead. So that's why we want to save the world. It's not because of us, but it's just because if care our offspring, then you would care. So that would be, right? That would be the problem. Okay, that would be the reason that why sometimes people would call them green terrorists, right? Because they do something very extreme, But of course, if they think the future is more important, then there are many, many generations ahead, then you can see that's why they think in that way. But whether this is correct or not, I don't know, but that's how you can justify what they're doing, right? I don't want to go to technical detail here. Since technical, then you can just skip. In case you're interested, this is the proof why you add the marginal benefit equal to marginal cost. But I don't want to go to detail for this one. But I think this is very clear, right? Because in terms of the government, right, or the regulator, you add up everyone's benefit because no one's harmed, right? There's social benefit there, right? The social benefit added up everyone. Yeah. So that would be the idea. Okay. So this graph illustrates one thing. Okay, is for the government, right, or the planner or the activist, they would try to do things way more than what we think. Right. That means that if we let the market work, usually it's inefficient. Okay? We'll show you later in the upcoming slide here. Okay, it's here. But anyway, before we do that, we want to illustrate one thing you learn in the principal econ class is two important properties of public good. One is called non-rivalry, we have seen, right? Because it's the other man consume doesn't affect my consumption. Okay? The second one is non-excludability, which means that if I use it, I can't exclude you, right? Suppose, we buy a warplane, buy a missile, build a expensive nuclear weapon, right? And you can't exclude one guy, say no, right? You can't kick him out of the country. Maybe you can, but in general, you don't think about that, right? You can't really exclude them. And that means that the main problem is free rider. Okay? You don't do that, right? You can't really exclude, right? In some sense, group project is a public good. Actually, it's called club good, but you can imagine the same as public good problem, right? 4 people in a group or 5 people in a group, okay? And then you don't do anything, right? Waiting for the project to be to be done, right? And if there's no peer evaluation, then you just free ride, right? Why you want to do it, right? Someone will do it anyway, right? So just free ride, right? I don't know what happened in your group, but hopefully not. Well, because that is different from learning, is different from usual outside you go to work, right? You go to work, it's a team, right? If you don't work, you still get money, which we're happy, right? But learning is a process that you have to invest to learn the knowledge. If you don't put in the knowledge, you don't know anything, right? The project that we do, the case study, is intended to make you to actually try to do something that is relevant, right? So hopefully you don't feel right, but it's hard to stop, right? So that's why when I teach undergrad, where the free riding is very important, I don't dictate what is a group size. They can, although it's a group project, I allow them to do individual. And I allow them, the work that they do is proportional to the group size. So they can do one person group, 2-person group, 3-person group, and they can't complain, right? Because they can all exclude, right? If they don't like that guy's not doing, then he can just submit without the name on that there, okay? But I guess in the master program, right, you guys are more grown up, right? You guys know how to solve the problem, right? I don't need to take into account. So, but that is how I solve it. So this is the usual you see also in undergrad textbook, is how you distinguish the private good, public good, or club good, or common good. And I don't think it's very important for distinction for our purpose. But private good is the thing that we used to see, right? The good that I consume and you can't consume and I can exclude you, right? And public good is I can't exclude and then I cannot consume at the same time, right? And right, club good is the thing in the club, right, where you can easily exclude people, right? You have club there, say you have a club and you have a nice club where you have nice furniture, nice food there, but you can kick out people, right? Only people pay can join the club, right? Like the horse racing club, right? And it's a thing, right? Also, the alumni club is also the thing, right? You pay, usually people go to the master program, the MBA program to join the club, right? You're the club, you're alumni, right? Only if you pay, you get in the club, right? But anyway, mainly you can focus on private good and public good. That would be fine. Okay? Common good is like fish, right? So there's a fish in the sea, right? I got a fish from the sea. You also can got, right? And no one can stop you because the sea belongs to everyone in the world, all right? But I get one fish and you have one less fish, right? And actually, this common good is a lot of issues, not just in the natural resources, but also like the health is also a big issue there. You know, we have vaccine, right? It's the antibiotics, right? Antibiotics is, the problem is if someone use it, right? Then the chance that the virus can mutate, right? That render the antibiotics less useful, right? So that means that if a lot of people using it, then you will harm everyone at the end, okay? And that would be a problem as well. But I mean, you can see there's a lot of things that create a lot of problems, okay? And I try to give you the reason why the public good, in general, you have a problem of under-provision, okay? And let's see the example. It's a present dilemma, okay? Suppose we want to, the benefit of the public good may be having the firework, for example, or having a park there, right, at 5, okay? And the cost of having the park is 6, okay? And we have 2 persons, okay? That means that, well, the total benefit of the park is 10, right? The cost only 6 is worthwhile to do the park, right? If government's there, then they will implement it, right? Say, we build a park and everyone pay for the cost. There's no problem. That would be end up in a good scenario. But the problem is, in general, government is not able to do that, in general, because government don't actually know how people benefit from that. Government can know the cost, but that can't know the benefit. But suppose the case we know the benefit, okay? In this case, if no one wants to give money, right? You imagine a charity problem, right? If no one gives any money, everyone free ride, nothing will be built, it's 0, 0, 0, right? If they all contribute, they say, okay, I'm going to share the cost, right? I want to pay for that. Everyone pay $3, right? And benefit is 5. 5 minus 3 is 2. Right? Everyone get 2, equally share. And if only one guy contribute to that and the other guy free ride, right? You get billed and the payoff is the free ride guy will get 5. Who benefit from paying, the other guy negative 1. Okay? And let's check what kind of outcome you can see. This center percent dilemma there. Okay? Look at the case. Is it everyone going to be good? Okay? No, because this case, this guy want to free ride. Right? If you want to pay, I don't want to pay. Right? And the same, if you want to pay, I don't want. Right? And if you know the other guy is free riding, why am I going to do that? I'm not going to do anything as well. So the only possible Nash equilibrium, or even dominant solvable, right? No matter what you do, I'm not going to do anything. Okay? 0, 0. Right? So that means that public good, even though it's good, will not be there. Right? It's not going to help. Right? End up in everyone's free riding. Okay? Everyone is not doing anything, even though you know this is good. Right? But this is bad. Right? Just like, okay? Like the plastic bag, okay? You buy the plastic bag and put your rubbish in the plastic bag, okay? Then it's good. And now you don't, right? Where you go? Put the rubbish in the back alley or put it to your neighborhood, right? Don't buy the bed, open your neighborhood's bed and put it inside, right? Or someone said, get the luggage, get the rubbish to mainland China, right? And or throw to the sea, okay? Well, actually, carrying rubbish to other jurisdiction is very common. Not just is in the case Switzerland, everyone knows Switzerland, right? It's a rich country in Europe, right? And they have most stringent rubbish law. Okay, so what do they do? Okay, Swiss people drive to France and throw the rubbish and drive back, and it becomes a serious problem there now. So that's why they check whether the truck, the car have rubbish at the back. Okay, and it's possible, right? As expectation, if something happened in Hong Kong, especially people near the border, probably they will drive the rubbish across the border. It's not unimaginable. Okay, but of course, I think in this case, Hong Kong now is not so expensive. It's still okay. But who knows, right? People may drive to the Sam's Club at the same time they drop down something as well, right? That's normal, right? But you can see the problem. And usually it's not easy to solve, right? So you can see how Hong Kong solved this problem, the rubbish thing, in the old days, in the 1890s, right? They spend a lot of money to educate people, keep Hong Kong clean, right? I probably know that. That means that what? They try to make this high, okay, to change this payoff structure, right? Education is the way to change the payoff structure. So that increase, everyone do this, there's a moral value to doing that, right? If you do the bad, they look at the bad eye on you, right? You become a rubbish dinosaur, right? That's how they call it, right? 垃圾龍, right? Something like that, right? 垃圾龍. Then this is the idea, okay? So, so that means that if you rely on the market, actually there's a problem, okay? It's just not efficient. And that's the first problem of the market, okay? Market doesn't solve this problem, okay? And someone would say, okay, that's why we rely on something beyond the market. We need NGO, we need government, we need company to solve this problem. Or collective action, we have to change it to solve it together, okay? So, one way to think about this is to, again, like charging a tax or subsidy, right? And solve this problem. So you can imagine one thing that government try to do, right, is education, right? I think you look at the government budget in Hong Kong. One of the big things they spend for Hong Kong government is two things. One is education, the other is health, right? Both of them actually public good. Right? Well, of course, national security also as well, but anyway, the two things used to be the largest two. And the question is how much they should charge, right? Or how government can do it. They have to estimate the preference, estimate how people want to pay for that, and tax it or subsidize accordingly, okay? That is called the Lindorff tax, okay? And of course, the problem is you ask people how much they want to pay is very difficult, okay? So that's why in general, what happened now is they call the cost-based charge. We do know here is like now what our Secretary of Health try to do is for the emergency room, they charge based on cost, right? If you not very emergent, they charge you more, right? So that is how the cost-based, cost-plus structure, and same as how we regulate our utility industry in Hong Kong, right? So how the electric bill, the price is cost-plus, right? But anyway. So the next is if they have to do it, government do it, how should they do? Okay. I don't want to go to detail, but I want to tell you this is a very useful thing. It's called the VCG mechanism. It's called Victory Growth Clock. Okay. The idea is very similar to second price auction. Everyone know auction? Okay. Auction is something like very simple. Okay. Like suppose I try to sell this thing. Okay. I don't know how much I want to pay for that, and then I keep increase the price until the last one say okay. Okay. And the price you pay, if the price is the price I stop, it's called the first price auction. If the price is the price that the second last one, will be the second price auction. Okay? Means that if you pay the highest, the price you propose, the first price. If you pay the price that is the second highest, it's called second price auction. And usually you would see the English auction where you go to the auction house where some guy goes up the price. Is English auction is actually equivalent to the second price auction. Okay? And you will ask yourself why this second price auction or English auction, or called the ascending auction, is good. It's because this auction is what we call the truth telling, in the sense that there's no point for you to fake your value. If you think this value worth 10 bucks, you say 10 bucks. Imagine this is our ascending auction. Okay, you value this 10 bucks. Okay, what would be optimal strategy for you? You keep in the auction as long as price below 10, you keep there. If above 10, you drop out. Right? In that case, if you win, you would have some surplus. If you lose, right, you just price above what you need to pay. Right? No other strategy can beat this one. Okay? So you just think, you don't need to think others. Think yourself. How much it value to you? 10 bucks, you stay into there 10 bucks. Right? Because whether you get your price to pay is independent of your action. You determine when to exit, only determine you win or lose. The actual winning how much depend on others. Okay? Because you win a second prize. Right? So whether you win is depend on your real one, but how much the surplus you get is based on others. Because you're not paying what you have proposed, right? You're paying what others are proposing, except you, right? Okay? So same here, you can extend this to idea of getting the public good. Okay? So it's a bit technical. I guess let's see. Maybe I can still go a little bit because give you some flavor what I'm doing. I mean, I don't go to math, but let's see how we do is, okay, in terms of public good, you just ask people how much they want to pay for that. Okay? Everyone tell the government how much I want to pay for this stuff. Okay? And government will try to say whether to adopt this public good or not based on your report. And then they have to charge tax and subsidy based on the externality imposed. Okay? And the externality is independent of what you're proposing. Okay? I'll give an example, and then that will be efficient. Okay? I'm not going to go to the technical detail. I go to an example. Example here. Okay? The example is very simple. Now, they are public good. Okay? If there's no public good there, everyone got 0. Okay? If there's public good, everyone value at $5. Okay? No public good, 0. Public good, 5. Okay? Next is how much the public good cost? $8. Okay? $8. Okay? And of course, that means that no one can single-handedly fund it. Okay? And it's efficient to have it because total benefit is 10, right? The cost is 8, you should bill it, okay? So how the problem is the government doesn't know actually it's 5 or not, okay? The government knows 0 is 0, that's no problem, but didn't know it's 5, okay? They need to ask people how much you're willing to pay for that, okay? And then after that, they collect tax, okay? So let's see the setup here, okay? And you can imagine that actually there are 2 guys there, and the guy number 3 is the planner, okay? And the only thing that is important is whether have public good and have no public good. 0 means no public good, 1 is yes, okay? And guy number 1 and number 2, if public good, $5. No, but the government have to pay $8 out of pocket. Okay? If nothing is billed, everyone got 0. Okay? Now that is the setup. Now we are going to tell you what the VCG mechanism is. VCG is trying to say the government ask guy number 1, how do you think that if we're public good? How do you think if no? Give me 2 numbers, okay? If the guy is honest, he will say 5 and 0, but he can report any number, right? But he will tell the government, if public good, this is my happiness. If not public good, this is my happiness, okay? And same for the government ask guy number 2, okay? How much he's going to happy if public is there, not there, okay? Number 3, don't need to ask because the guy number is the planner, so he knows. If you bill, you have to pay $8. If you don't bill, get 0. Fine, no problem. Okay. Now, if this one means that if everyone tells the truth, report the real truth, okay? And the optimal thing for government to do is just trying to bill the thing is 1, right? Because add together, it's efficient to bill, right? You say it's 5, you say it's 5, the cost is 8, add together the surplus of 2, they bill, right? But however, if there's only one guy, you call V minus I, take out the guy number 1, only guy number 2 there, they will not bill, right? If just one guy, not going to bill. Only 2 guys is bill. Is that clear? So that means that V minus I is taking out the guy number I there, take him out of the society, okay? What will bill on you or not? Okay, it's no, okay? Now, what we're trying to tell you is the formula that is trying to say the externality he imposed, okay? So you can see, okay, is how much guy number 1 or I is paying depends on how much the society accepts himself, okay, is going to get if the efficient things happen, okay? It's trying to say, okay, everyone give me the report, okay? And then I decide what to do, okay? Under what to do, look at the social welfare, okay? Except that guy, okay? Put it this way. This is what? This is, if you look at guy number 1, how much he's going to pay depends on 2 parts. The first part is look at the society on 2 guys, right? Look, ask guy number 2 and number 3, add together how much the society is getting without that guy, without guy by the way, right? So society without him. What should they do? Okay, accordingly. And what should they done? Decision without him. Okay, because without him, he's not building the public good. Okay, so this externality. Look at the case where with him we build a park. Because of him, we change our public decision, right? Then look at how much he's changing. Okay. Then this is the park that we will charge to him. Okay. And this is called externality. Okay. And look at how much is paid
It's no matter what he reports. His presence only affects whether the thing is getting billed, not into the calculation. So that means that in this system, how much he's paying, okay, is not dependent on his report. His report only affects whether the public good is being billed or not billed. If billed, this is social welfare. If this is billed, so that means that if his report doesn't change the public decision, you not pay anything. Okay? He only pay if he's changing the public decision. Okay? And in doing so, okay, this is a system where things got billed. Okay? I know it's kind of abstract, but I try to give you some flavor of this same as second price auction, right? What you report, okay, only you will determine the outcome, whether you get a good or not, right? So that means that in this case, whether you report United public good or not, affect whether the public good is provided or not. And how much you actually pay for that or get somebody for that is how much you impose externality, right? Because you change the society decision and you look at how other people are affected with this externality, right? If the presence of your report doesn't change the social outcome, you don't pay. Or the action doesn't change the social other people's payoff, you don't pay as well. Okay, so that is the two part there. I know it's kind of complicated, but this is no different from second price auction, the generalized version. Okay, and this is very often that people try to do. Okay, as I said, it's technical, so if you don't really get it, it's fine. Don't worry about that. But I try to give you the idea that how it can be done. Okay, if you want to fully understand, you will take several chapters to do it. Okay, but I just give you the idea how usually this can be done. Okay. So here is if you reply, it changed it, it got builded, you just add together, okay? Guy number 2, how much payoff he's getting and how much total cost, right? So if nothing is billed, it's 0, okay? So basically look at how much you pay, right? It just depends on 0, this is 5, so you pay -3 there. So which means that they have to pay $3 for each one. Okay, everyone pay $3. Okay, for that. Okay. Now before the break, now we learn 2 things, right? First thing is actually several things, right? The first thing we know is public good has a lot of issue there, right? Public good is I consume, doesn't affect your consumption. And I cannot, when it's produced, I cannot exclude others. Oh, that's a public good definition. And the efficient production require you add everyone's benefit against the cost. Okay? So if you can't remember that, it's just like 1.4 billion people, right? The benefit multiplied by that, right? Against the cost. Right? That's how efficient. And you learn the precedent dilemma imply that in general it won't be efficient, right? And how do you solve this problem, right? Government has to do it. That is called the Linda tax or Pigovian tax, right? Government have to charge. That's why we see a lot of tax, right? Our water price, right, is expensive because you buy it from Guangdong, right? But also the other part is the Paiwu fee, right? It's like the part that says conservation fee is also equally expensive, right? And why? Because the government have to handle those, right? Have to charge it for that. Right? That's why into this account. And the next question is, in general, government doesn't know how much people want to pay for that, right? How can you know how much we need to pay for X and Y and Z, right? It's very difficult, right? So how do they do that? Usually they would, sometimes they would do the VCG mechanism, okay? Ask you to tell how happy you're paying for that, okay? And design a system to compensate people, right? That is how you're going to solve this problem. Or if you think the good is marketable, you can do second price auction, right? Second price auction would equally solve this problem, but you can generalize the second price auction to this, right? Because you can see this VCG, the first guy is called Vickery, and those who learn auction before Vickery is the guy who get the Nobel Prize for studying the second price auction, right? So that is very often used in business practice, right? And but they can generalize to look at how the public good is being implemented there, okay? And probably you ask, okay, why I care about public good? We are all business manager there, right? But this is very general in the sense that if you're a planner or the government owner, so company owner, you try to solve the problem within multiple agents and you don't know the information, then that is how you can solve this problem, right? Imagine that the question is in general, right? You consider a case where the company have different departments, right? And different department will have different proposals, right? Whether the company should spend money on this project, or we develop our company direction in this or that, right? And then how a CEO decide what to do, right? One way to think is ask them to report, right? How well you would be if you're here, how well you would be there, and then you can decide according to the report. Right? That is very often they in the literature they call mechanism design or information design, and it's very often used in business world. Of course, there's some drawback of this mechanism, but this is the one of the most useful one. I mean, everyone use it, and using computer science, they also do that as well. So look at how the mechanism design in the online system and people transit, because you don't know the other people information, right? And you have to make collective decision, and this is very useful. And you can imagine that's because there are so many smart contracts nowadays, right? Everything can be online. I mean, this thing can be automated, and this one of these things are actually implemented there, right? You can imagine the same as the congestion, right? In the airspace, right? When the airport, right? The runway is very congested good, right? If there's a delay, suppose the weather is bad, okay? And now all the flights have to be rescheduled, right? And who get the chance to go ahead, right? And who can get in or get out, and small plane and big plane is very different, right? So you can ask them to do it, right? Because auction is good if you talk about one good, right? But you are also, everyone is talking about the whole schedule, right? It's not about who go first, right? It's asking who go the first, who go the second, who go the first, so on and so forth. And these are very useful things to be implemented to solve the problem. But and you can see, right, there's externality there, right? And if the big plane go and small plane, so on and so forth, all these things are related. Okay. After the break, I'll briefly talk about externality, and then after that, I'll talk about the financial market, how the public good and adverse selection together jointly imply we have bid-ask spread. Okay. That would be the goal today. Okay. So let's a break of 15 minutes.
應該係5減3係呢個元素。
OK。
sorry，唔好意思，好明顯嘅。你係唔要嗰1號，即係話1號仔話要做啊嘛，即係加晒所有人之後，即係話你加1號仔要錢，1號仔俾嘅錢就係話佢如果加晒所有人，跟住所有人變過嚟啦，咁變嗰個嘢嗰陣時，除1號仔之後就計203號嘅 social welfare 5減8。因為你第一個係你呢個嘢，你嘅 payment 咧就係A 減A 嘅係咩咧 ？A 嘅話就係話你唔使 I 嘅啫，1啦，我哋要加埋 B 嘅2，再加 V 嘅3。咁因為你喺度咧做咗嗰嚿嘢整咗出嚟啊嘛，咪咁即係呢條友佢俾你5咯，係啊，個金咪減晒，即係你嘅存在咧就係令到個 social welfare 其他人咁 B 嘅話就係話你喺度就冇氣啦嘛，即係你喺度就唔起㗎啦，咪就係0啦，係啊，咁3個就都係0啦，咁就係0，係，咁即係你嘅存在導致大家都減咗3，其他人，咁所以你哋而家。因為你做你唔理自己㗎嘛，你就影響到你做，你嘅存在影響你做同唔做嘅啫。但係你嗰個你做定係影響其他人㗎，所以你要賠翻俾人哋。
咁但係呢個情況底下，其實咁你講呢個人佢唔知自己係個人嚟㗎嘛？你個社會有咁多個人，咁你係咪應該將呢個負擔攤翻俾？
唔係你就係俾，因為你喺度影響到個，你影響到做唔做。
咁我點知道係佢影響定我影響？
唔係你 report 㗎嘛？即係你 report 出嚟我計㗎嘛。我呢個1咧係我計咗個 social planner 計咗出嚟，我做嗰陣時加晒咁多個人，因為加埋你嗰個之後咧，影響到我做。
咁唔通其他人全部都？
但係真實即係真實一個社會，譬如我要起港珠澳大橋。
唔係，咁我咪問晒所有人咯。
即係但係起港珠澳大橋，其實呢啲真係會咁嘅咩？即係有做嗰啲咁嘅嘢。
咁樣做就會，咁樣做，我哋政府梗係唔係咁，但係正常嚟講，
即係呢個世界其實係一個
唔係你可以咁，呢個係你咁樣 design 嘅，唔係政府係唔會好少做咁嘅嘢嘅。但係如果你係個機構嘅老闆，你做呢啲嘢嘅。即係話，如果我哋嘅茶水房要唔要整啲咖啡先？要免費咖啡打500嘢先，咁咪睇下邊個 department 要啦，咪邊個 department 咁都咪差除幾多錢咯。
用者自負。
有啲是用者自負咯，但係佢一個因為有 externality 唔對用者自負就係話你因為你改變咗你決定。
唔係喎，但係其實咧，譬如即係有話 person one，但係 person one 其實 enjoy 晒5，咁佢係減0。
我唔冇佢㗎，唔包括佢㗎。我計 benefit 唔包括，即係因為你嘅存在影響到我哋嘅社會決定，咁影響到其他人我先計。你自己我唔理你㗎，你自己開心冇所謂㗎。你自己中意嚿嘢1億都冇所謂，唔 care 人哋嗰嘢。
而家講緊譬如係譬如第一個 case 係1個人嘅話，我唔會起呢樣嘢；2個人我先會起呢樣嘢嘛。咁第2個人佢就 bring 呢個 free。
每個人都 bring 呢個 free to society 咯。
但係咁其實你可以如果都唔起咁咪都0咯。
咪0咯，係唔使咯。咁咪仲0咪冇咯，咁咪即係你真係想起啊嘛，起係唔非常。
但係 society 嚟講其實係2啊嘛，係咪10減8？
係啊。
咁我放呢一嚿嘢，我係為咗點樣？
我而家要佢話，因為政府唔知道要起㗎嘛，你要問佢哋要唔要起㗎嘛。
我要問佢哋起唔起，我唔係應該要點分係10減8係咪？
因為你唔話俾你聽10㗎嘛，邊個10？我唔知10㗎，你話俾我聽，我先知10。我問你，最大嘅邊個做呢嚿嘢？個問題我唔知你幾多。
係啦，咁
所以我問你，你話俾嗱，你個 plan 起嘢幾多錢？你起值對你講值幾多錢？唔起幾多錢？唔起0啊？你個 plan 你起嘢幾多錢？起2值幾多錢？
你話俾佢聽，你話聽5，有聽5，有俾人5，
實際上 market 個價係幾嘛？
成本係8，
成本係8。
government 知道係8嘅冇問題。
我個5嘅意思
係你話俾我聽，你就對你嚟講起咗佢哋值5蚊咯。即係佢聽起港珠澳大橋值幾多錢啊？5蚊，哦你話5蚊，你話5蚊，你話你我5蚊，哦咁我成本係8蚊，咁我起咯。咁你點樣 share 呢個8蚊啊？
其實呢一嚿嘢係
monitor 嚟，你話俾我聽㗎嘛？嗱，你預備幾多錢？
咁其實起唔起個決定都係我覺得係。
我計晒所我要 society 嗰個我計咗，你話5蚊，你話5蚊係咪先？咁咪即係10蚊啦，咁成本8咪起咯。你預備5蚊，即係你預備5蚊嘛，我叫你俾5蚊，最多你俾幾多錢啊？又5蚊，又5蚊，咁我咪起咯。咁我嗰個成本8蚊點樣去綜合翻？就喺度。
即係我個8蚊點樣去湊翻？
係啊。
就係阿 B 俾翻3，俾翻3蚊，咁阿 A 俾5蚊。
你兩個都俾負責，政府最貼底㗎，政府最貼底㗎，有冇底2蚊？係啊，政府要俾個兜底㗎，但係你俾3蚊，你俾3蚊咯。
嗱，譬如而家個 case 係2個人啫，咁譬如我3個人咧，
一樣㗎嘛。
咁我3個人嘅話，每個人收3蚊，咁即係我負責錢。
係啊，不盡包量就係唔包量，呢個係個問題，不盡包量最大嘅問題就不盡包量，最鬥大政府鬥大嘅。
即係幾講呢個咁大家覺得可能即係大家嘅 benefit 呢邊100萬，大概俾10億嘅
政府會俾。我係有陣時可以賺可以賺，可以賺可以負，唔一定但係只能夠話俾你聽呢嚿嘢咧，結果就係 social 係認識，大家都會覺得到。佢個 benefit 係5蚊嘛，要俾3蚊嘅，睇下5蚊 net benefit。係你要俾3蚊。
但係譬如我俾3，你俾咗10億啦，我每個人我覺得我 benefit 10萬，跟住咁所以即係你個 population 好大㗎嘛。係啊。我10萬減10億咁出嚟嗰嚿數嘅意思係。
即係嗱，你呢個譬如話，即係話，
因為我嘅存在。
如果你嘅存在係影響到佢係起唔起，或者起幾多，咁咪要你俾好多咯。
咁嗰嚿數係9.幾億咁。
但係你淨係話俾你聽，你要俾幾多，你係唔俾㗎嘛？你嗰度係10，你講俾你10萬，你話淨1蚊，你咪俾咗幾多蚊㗎？唔會高過你要俾嗰樣嘢。
所以其實我覺得我直頭。
但係你同我10蚊咯，你唔會講低過佢㗎嘛？因為你講幾多錢同你係冇關係嘅。你係講緊你對其他人影響點？
咁我嗰9.幾億係現開人嘅，即係如果係呢個example係我應該嚟。
唔係因為如果你係俾10萬，過咗10萬，跟住咧
10萬減10億。
唔會，唔係就你自己係所有人，因為你而起咗，減咗佢唔起，咁你先會影響。
係啊，呢一個唔係我自己。
A 就係你，因為你嘅 report，我哋決定咗要起啦，咁咪所有人嘅成本加埋你嘅 net benefit。
唔係淨係得我自己個 benefit。
唔係你
人哋嚟嘅，
除咗你之外，除咗你之外。
全部唔係有10咩？
即係我覺得個飛係100萬，而你個飛都講100萬，唔會咁樣夾埋200萬。
即係你覺得100，OK啦，如果照我都係條問100萬人，問晒全班人，咁我點樣計呢個咧？唔睇你，睇下所有人加埋幾多錢。
一個5係加埋㗎。
係啊，所有人都加埋。係啊，所有人呢個計。
唔係話10咩？唔係話10就係因為有2個係。
唔係，你點解要做？就因為嗰個係值10蚊，咁咪做咯。
個10嘅原因係因為每一個人都係5蚊。
係啦，所以你先會做啊嘛。係啦，就會做。
咁10就減翻我個 cost。唔
係，但係呢度唔係咁樣減嘅，你係計個 social benefit 咯，個數字。你睇佢減，除咗你之外，total social benefit excluding you。因為你係講 externality，唔係講你自己。
即係如果講租大嘅原因係10億，再減翻10萬， 就係你啦，呢一個就係10嘅，係啊，咁所以其實我要記就係我自己揀咗我覺得值嘅10萬咯。
係啊，你講值幾錢？
係咪咁意思啊？
係。
哦。
其實呢邊你都有10億嘅，所以你減翻佢，冇一個，即係你大家好多人㗎嘛，所以你。
我想問嗰關一個，咁係咪即係而家喺度正嗰個mechanism係比較低啲？
佢就正接我呢個，但係呢個係正常嚟講係，如果你係可以，如果你係公司老闆，你可以。
即係我想問下，即係其實嗰個我呢個應該係即係佢計算更加有個數啊，即係
如果你做簡單豬，呢個就係簡單豬啫。
係咯，就係
簡單豬就係話你要簡單豬就係個問題就係點樣見得成功方面。就係呢個就係呢個就睇咗見得成功。
我就想知道咧，佢哋嗰個
唔係你話俾我聽啊嘛，我問你，你話俾我聽，你話俾我聽㗎。我問你，你講咗幾多錢你嘅就聽嗱，你話5蚊，你話5蚊，咁我即係話。
但係譬如我哋呢個，我當大家要俾一，即係我哋咁樣去人俾條數出嚟，咁我哋覺得喺呢個其實係冇 market 嗰個，
冇得 market 㗎，market 你係冇 market 係啊。
即係我哋覺得起條數出嚟之後，咁我覺得好難，大家分錢難嘅，但係實際10億嘅，
咁唔係咯？唔係咁你唔會起㗎嘛？你唔會起，你唔會起㗎嘛？如果係咁嘅話，你呢個1係因為計晒所有人之後都值，你先會1啫嘛。
即係簡單啲講就係算係全部人一齊一個人。
你要係呢個點解 A 係1啊？係因為加晒所有人 A 係多。
如果即係話係反正佢真係每年就冇睇上面嘅，冇分唔係啊，係啊，咁如果佢計到嗰個
你唔復今日落我聽啊，問你，我聽唔到，俾咗幾錢？咁你個問佢咯，咁咪照計咯，加埋1，係咪超過個個都係？如果係就起咯，唔起就唔起。你問你幾錢啊嘛？你問你幾錢？咪純粹計幾多錢？係啊，問你嗱，你嗰度係幾多錢？係啊，10萬，佢話5萬，加埋15萬，100億你唔俾咯，咁咪唔俾咯。加晒所有人，要有起我先，你先要俾錢。咁咪你唔俾錢。
都係，我哋嗰個 information 好低。
咁我問你，你話要俾幾多錢咯？
但係點講咧？其實你 market 即係 market 個 system 應該譬如我買，即係我講啲比較房產就咁係嗰個，如果就賣咁佢叫即係15%即係10蚊嚟㗎嘛，咁咪叫8蚊你睇按可能即係有升買隻條數，但係你呢個係唔好嘅問題，
就係問佢咋，齋問佢咋，我純粹齋問佢啦，要俾幾多錢？
都計翻㗎。
咁計嘅，所以有機會，但係佢就係問你個稅，問你要乜啫嘛？問你啫嘛？你中意做唔做？即係純粹自己可能係政府包底或者政府收翻。但係通常政府點做就係問啲議員話俾你聽咯 ，S 計㗎嘛。如果解決咗嘅話，我哋唔使咁多麻煩。呢個世界就已經解決到問題，但係解決唔到，好難嘅嘢。information 就好難，你嗰陣幾錢，俾咗幾成，好難做。
咁理論上，即係理論上主要咁計。政府更多嘅 market 呢個 system，
係好麻煩㗎，即係等於譬如話我係 company，我而家有個電腦，我要升級，我升級，可能對你嘅 department 有幫助，你啱，我 cost money。1億我而家喺 Facebook 話而家我要整個啲 chips 係嘛，1億，咁我點樣 share 阿 mon department？marketing 又要我可能要出錢，咁但係我點樣 share？我叫你個 department 咪 call 我聽咯，我入1億嘅 chips。你俾幾多錢？佢俾幾多錢？分翻俾佢，收大嘢大。跟住我係一個部門，
如果我話我都會需要呢樣嘢嘅時候，就會導致到全間公司都決定去做嘅話，個老闆就會撇除咗我，跟住就問睇晒所有部門佢哋出嘅價錢，再減翻公司自己貼嗰個即係個 cost 之後，突咗 嗰一月就係分紅。
係啊，就係計翻你攞 allocate 翻嚟。
呢條式就重複做好多次，
做一次啫，你淨係計個。
唔係咁
根據你嗰個嘢加去。
呢個部門 A 係我自己啫，呢啲係。
哦，係。
跟住可能到另一個部門就部門 B，跟住又擺翻。
係，佢計咁咪計。
咁加就做。
係啦，每個部門都要計一次咯，每個部門都係上一。
嗰個就係可能做嗰個 R&D 或者排個升升嘅總。
係。今日決定咗個買咗幾多，決定咗要買幾勁嘅 super computer，梗係點樣分啲錢咯，計出晒。呢啲係其實喺 business 嘅應用好用嘅，你加埋嚟，你睇 business 因為。
但係如果你報上去話你嘅開心或者你得益程度唔夠高嘅話，可能會導致到件事。
咁唔做咪你自己都蝕底啫嘛，你冇蝕底㗎，因為你報幾多錢對，你報幾多錢對你嘅俾嘅錢冇影響。係。你只係影響咗做唔做，所以你唔需要講大話。你報幾多錢唔會影響你嘅計佢，你唔會影響。
當然有啲人可能搏低啲嘅，即係個夾埋都一定會做㗎啦。
我係低啲嘅話，對你個你哋嘅 pay 唔大。你報幾多錢就影響做唔做啫。
即係喎，因為係 B，因為係叫你嚟入嚟㗎嘛。
係啊，而家所有人嘅我同你講大話，所以呢個就點解咁犀利㗎？你點樣吹都冇所謂，你吹對你冇好處。因為你只係你嘅影響影響到你係。
但個問題係點講咧？譬如話你個部有某一班人覺得嗰嚿嘢值10億，但我覺得係報道有啲跟住投入去。
如果你吹細咗嘅，咁咪唔做咯。你話俾我聽，你覺得好似要咁，但係有機會你唔做。你嘅 report so far 就影響到你對人哋影響。如果你個 report 唔影響到嗰個結果嘅話，
但係你報得大有影響。
就俾你諗下，second price 你報幾多錢唔會影響你俾幾多錢。係啊，嗱，如果佢第二個係一樣啫嘛。你即係你個報價影響到我要唔要做㗎嘛？你俾幾先人哋，你對人哋嘅影響，因為如果你
我跟住講嘅，即係你個 band 就計，即係冇影響。但係我做唔做咧就會影響。
係啦，冇錯。所以你報咩冇所謂啊？你報亂做係影響你自己嘅，唔影響我。
我亂作跟住考，
但係如果係唔做係你咪接賴嘢咯。
咁就其實計唔到先咩？好難計到先咩？
有你唔加齊你啫嘛？你話俾聽咩？但係嗰個
理論上係咯，
唔係就係你 report 啫嘛。但係如果即係我係困難，我係公司老闆，問下你我咁樣做你幾多錢先？咁要幾多錢到幾多錢先到？講我聽咯。
喺公司係 OK 嘅，但係實際上可能係。
即係 public goods 係但係 company 就 public goods。我商店應該係成間公司咯。public goods 之後 public goods 之後，我 consultant 點解你講就話個超電腦俾佢爆炸嘅，因為你就有可能中意或者公司做咖啡機嗰種要收拾嘅話，就可能啲咁要做得去會上面，即係呢個都唔存在。安全性標準，譬如話你做廣告都public goods俾你公司。譬如話我公司買 Apple，
即係其實佢個根本就係大家可以 common share 嘅。
係啊，即係我做緊就係 common share，譬如佢總公司做緊嘅廣告，全個所有人都有利。咁但係可能佢哋有利，呢個你冇咁有利嘅，梗係夾過呢啲係。
但係如果你即係我假設有個雖然你但係我如果係一開始報得太細嘅話，咁可能會做
咪導致我唔做咧？
可能成間公司整緊。
係啊，所以你夠，但係你唔會有，但係你唔會 not is not your interest。
但係如果譬如我依家係1號啦，譬如我1號我報得好細嘅，到到第2號嘅時候，呢個就細咗。
但係我做唔做決定於你嗰個嘢㗎嘛？你影響咗我做唔做啊嘛？你嘅 report 就影響咗我做唔做。我係計晒所有人之後決定做唔做。即係嗱，我做唔做係計晒你所有人 report 俾我聽。哦 ，benefit 大家 report。但係你嘅 payment 就係話，因為你嘅 report 影響咗我做唔到，咁我先至 pay。如果唔係，你嘅 report 冇影響我做唔到，冇 pay。因為你影響咗我做唔到，而導致有其他人影響到你啦，咁你咪 pay 嗰啲。 Hi. So today, most of you feel terrible. I don't know, terrible. Is it because of stock market? Temperature. So most of you okay. Some of you think very fast, some of you think very slow. So very diverse. So today I'm too fast. Okay, I will think about that. So people think that is too abstract to be true. So let me repeat what the VCG is actually doing. Okay, the VCG or the mechanism, the mechanism design, is trying to say there's a planner trying to do something, but what optimal to be done have to based on what the people information has, and the planner doesn't know, right? For example, you can imagine the company try to do maybe try to have a coffee machine, right? Very expensive coffee machine there, right? And or a supercomputer, right? The question is whether it should be built or not, right? Efficient one. And the question is trying to ask different department how much you want to pay for that one, right? How much revenue going to increase if such computer is there, or expensive advertising program is being done, right? Ask different department to propose whether he want to pay for that advertising or the supercomputer, right? And based on the information submitted, right, then the company owner or the management decide whether to go ahead or not go ahead, right? Based on everyone submit, right? As long as the benefit more than cost, he will do it, right? But the problem is you have to ask people to pay for that. How you pay for that is looking at whether your proposal, including your submission is going to change the outcome, right? If your proposal is not including you or not, doesn't change anything, you don't pay, right? You are paying is because how the overall company, different department, the profit is going to change, right? With you, I do it, this is how much the benefit other people are getting, and if we don't do it, it's not. The difference is the money you pay. You only pay for, because of you change the decision, right? So your report only change the decision or not. And how much actually you get paid or compensate depend on how this change in decision affecting the total benefit of everyone, okay? So that means that the design is in such way that you don't want to tell lie. You want to report me the truth. And I can decide whether to do it or not, right? Because changing your number doesn't do good to you, right? If you tell lie, doesn't do good to you. The same as you imagine second price auction, right? You tell a different price, it only change whether you win or lose, right? If you lose, you don't pay anything, right? If you win, you pay not your bid, but other people's highest bid. Same idea here, right? Your number you report only change whether we do this or not, okay? And how much you pay depends on how other people report, right? If your report change what we should do, right? You affect the society, right? Look at how you affect others. And the difference is you pay. So it's not something complicated. And as I said, this is actually can be implemented in business and actually implemented in a lot of online system, right? Because of this being pay and get pay, and this is very normal, okay? And hopefully it's not too abstract to be true. But as I said, I'm not expecting you to fully understand the VCG because that would be too crazy for you to maybe think. But you can imagine second price auction, right? But it's the same idea, right? You don't want to overbid, underbid. You just want to bid, right? The same idea here, right? Because you're winning or losing or is not going to that is the matter for your report, right? And your payment is depend on others' report. Okay. In that case, everyone want to tell the truth. Okay. Is public good does not have Pareto? Yeah, in general, it's not. Right. You can see the prisoner dynamic there, right? Everyone don't want to contribute, right? Because if we ask to do it, we don't want to do it, right? We need some collective action to do it, okay? And either here we have VCG mechanism, it's a planner to decide whether to do it or not. Or we have a system, right? A smart contract, right? Decide whether the voting will happen to be there and implement. Okay. Will technical up? No, technical part is not there. But I'm just telling you that, I mean, hopefully that would be useful. Want to get afternoon tea? Maybe let me think about that with the TA. See if we can do something during the case case presentation. But there we should do VCG mechanism to elicit what you want, right? I think in general, if you do the thing then pass, it's not an issue usually. But whether you get A minus or B plus depends on how well you do. Okay, I think in general, right, most people would get B plus or above, right? Unless you are not doing the job, right? So I don't think there's an issue there. So let me quickly do with externality, and then I will go to some more interesting part because I think go to the market, financial market more fun. Okay? So public good is a type of externality in the sense that it's like someone produced a thing, everyone can consume, right? So I consume cannot, once you produce, everyone can consume. And also there's a negative externality there. It's called the pollution, right? If I pollute, I feel bad, right? I get the bad air. But others also get bad air as well, right? So that is an issue here. Okay. So the classical econ theory would say, okay, that's not a problem. According to the Ronald Coase, a famous Chicago economist, and if you know Hong Kong economists, one is called Stephen Zhang Wuchang. One of he always say he's a good friend of Coase, and he always talk about one thing is very important is even though the externality, property right, if well defined, can solve the problem. Okay, you allow the market exist. There are no transaction costs. There are good property rights, well defined. Actually, external is not an issue. Okay, for example, the public good problem is if we can have well-defined property rights of national defense, okay? Or we have property right of the firewall, we can exclude, it's well-defined, then there will be a market, they can negotiate, they can solve the problem. For example, imagine the classical example will be there is a river, upstream there's a factory, right? the production can pollute the river downstream, and downstream there's a farm. Okay? And if there's no market there, then the factory will produce a lot of good with a lot of pollution, then hurt the downstream farm, right? And it's not efficient, right? If there's no market exists to solve this problem, right? Of course, if there's a market, there's a problem being solved. For example, suppose the river, the clean river, is the property right of the farm, right? That means that if the factory have to pollute the river, have to pay the farm to do it, right? Only they would do it in the case when they negotiate, right? And they will equalize the cost of pollution and benefit of pollution, right? So as long as the benefit of pollution is more than the cost of pollution to the downstream, then they can settle a price there, right? Pollution will be efficient, right? Suppose the pollution worth $10, right? Cost of pollution is like 6. They can settle down anything between 10 to 6, then pollution will happen. Market efficient, right? Or the pollution is more costly, right? Pollution may be cost $20, benefits 10, right? Then there's no way the upstream factory can buy the right to pollute, right? That is what Ronald Coase, he said, right? As long as the property right is well defined, it's no problem. As long as you can allocate this, okay? But of course, it was very clear that property right is not well defined in the real world, right? So that's why, according to Ronald Coase or this line of people who Chicago would think it's very important to well define property right and reduce the cost of legal process. In that case, all the externality will be solved here and there. Okay, so that's why we need a rule of law. It's very important because that's property right. If property right is well defined, then say suppose the farm cannot sue, then there will be a lot of pollution. Will be inefficient, right? And probably everyone knows carbon trading is kind of this idea, right? It's whether you can pollute, right, based on that, right? So, so that's one solution. This would work if transaction cost is not so expensive, right? Because of, say, it's very difficult for the two to negotiate, right? So that's why in Europe, how they solve it is there's a centralized market to trade the carbon quota, right? So that solve this kind of thing, and that actually help finance industry, right? That's how they trade off that. And similar as we said, this is called the Pigovian tax in general, right? If the government thinks the social benefit more than social cost, right, then they would do the subsidy, right? That's why education is subsidized, right? Healthcare subsidized, firework is provided by the government, right? Or many parks, so on and so forth, right? And marginal benefit less than marginal cost. That's why we are paying for the plastic bag to throw the rubbish, right? We have to pay extra for water because of the water treatment, right? So that's proposed by the Pigov, okay? But do look that there's a problem. How can you get the benefit and cost? Very difficult. That's why we have to sometimes rely on VCG mechanism we said, right? Everyone report the benefit, everyone put the cost, right? And then that's also efficient, okay? Of course, this is too long time ago, right? But VCG mechanism are way after that, okay? After that, so there are private solutions as well, okay? If this thing can be excluded, right? For example, zoo, right? Usually, if you go to the zoo, doesn't increase the cost of the zoo, right? Unless you throw rubbish in the zoo, right? Otherwise, you go there and see the animal actually hurt no one, right? It's probably good, right? Theme park or highway or airport. But the problem is it's public good, right? So no one will pay for that. Okay? How do you solve this problem with zoo? The zoo is, if you gate there, you pay for the price, right? Look at Ocean Park or the Disney Park, right? If I go there, actually hurt nobody, why pay, right? But if no one pay for the cost, then it's not under provision. So make sure it's not under provision. They set the price gate there. The theme park, highway, airport, right? Look at why China highway, right? They build so rapidly, right? Because of they can set the price, right? And people always complain about US and China and say US, the highway built so slow and China built so fast, right? Because China, they can charge, right? US is very difficult, right? There are very few places you can charge, right, in the US, right? The federal one, they cannot charge, right? The local one, they can charge, right? So that explains if you can close up the thing and then you can do it. At the airport also, right? So, of course, the problem is someone is excluded, it's not efficient, right? So say, I want to go to Disney, but I have to pay, right? But you want to pay, I don't want to go. So exclude me, right? Of course, my risk to pay is very low, right? I don't want to pay more than $100 to go there. But anyway, they charge several hundred, right? It's efficient to have me because I go there actually affect nobody, right? But I don't want to pay. I excluded from the club. Okay, and in general, it's still under provision, right? But at least better than no one is there. If you allow this to be privatized in some sense. Okay, so that's for profit. The other one is non-profit, right? And you know many World Bank, development banks, NGO, charity, right? They are non-profit, right? And they are not for profit, so that's why they can try to provide more there, right? It's one way to do it because they're not for profit, so they can provide and they depend on charity, right? They want donation, right? So some of you ask why we have NGO there, right? No one will ask why we are firm because we all for profit, right? And why have NGO and charity? Okay. The issue here is similar to the Darwinian idea, right? Survival of fittest or the social norm arise. The social construct is try to have this to achieve the efficient outcome, right? We pay a cost to get to better equilibrium. Okay, so that's why this explains a lot of social norm. Although some social norm look crazy, but that's how we get there, right? And because you can imagine why we have what we call the green activists or the green terrorists, right? It's because sometimes it's we don't look far ahead enough, right? But these guys are looking thousands of years later, right? Or millions of years later, right? So they look far ahead enough and they try to help us to commit to a better outcome. So that's non-profit. And of course, these days, actually, we figure out that even the NGO is not solving all the problem. So that's why you notice, you guys are the finance practitioner. So you see this kind of term a lot, right? And in the financial statement, you see a lot of ESG or CSR, right? And green bond or this kind of stuff. And you probably ask why this would happen, right? And it's because of sometimes consumer or investor have preference for that, right? Suppose you're given two good, right? One good is say it's environmental friendly. The other good is it's going to pollute a lot of stuff, using dirty technology. Then people actually want to buy for that, right? Although they don't want to pay a lot for that, but if very similar, they want to pay for that. There's a premium for that, right? So that's why you arise for that, right? Just like the ESG and CSR. Why company want to do that? absolutely no reason, right? It's not for profit. But the thing is, if they do this green stuff or nice stuff, consumer want to pay for that, or the investor willing to accept lower return for the green bond, right? And these are the reason why this can happen, right? Although collectively, we can't really, individually cannot solve the problem. But collectively, we think green bond is a good thing. Everyone agree that green bond will have some discount for the bond yield. Then it's okay. Then we solve the problem in some sense, right? So as I said, right, if people want to pay for that, then that's okay, right? Then that solves the problem, okay? And the reason why we have ESG and CSR all together is to solve coordination problem, right? Why the stock exchange have to dictate every company has to put the CSR and ESG there. Not voluntary, right? Because only one firm do it, not worth to do it. If everyone do it, we go to the good equilibrium. Okay? Remember the model we said in game theory is the coordination game, right? Is the higher and the I forgot, the big animal, small animal, right? If everyone go for a small animal, not very good. If we all go together, go to a big animal, we finish with a good outcome, right? Just one company doing that is not going to help. If everyone does it, then it's good. So that's why the stock exchange would dictate this kind of thing to be there, okay? So solve the coordination problem, right? Everyone have to announce how it conform to this, okay? And also consumer also coordinate, right? In the product market, in the financial market, right? So that is how this being done. Is that okay? Now I want to show you this very interesting model. This model is purely finance, okay? So I hope this one will be easier to absorb, okay? It's a trading model, okay? And this model is 1985, it's a long time ago. So that's why this modeling technique, the model, is we are related to the US stock market, New York stock market in old days, okay? And everyone would know, I guess, in this room, would agree that now the current market is double auction, right? Is if you want to buy, you send the order to the computer there. You want to sell, send there. They automatically match, right? If not matched, they will be there, right? There's no one in the middle to match the buy and sell, right? It's computer they match, okay? And before 1990s, the New York Stock Exchange is based on a dealer system, where there's several guys would call it dealer. The dealer will be there to quote the buy and sell price. Okay? Suppose the price, people believe the stock X is $100. Okay? He will stand to trade to buy in the stock at 99 to sell at 101. Okay? There's some difference there. So this model tries to explain this difference. Okay? And probably you would say, okay, in the stock market, we don't have this anymore. Okay? We don't have this buy and seller. But you can look at the foreign exchange market. The bank is doing that, right? You go there, you can always buy and sell at the same time, right? And also, although we don't, in current stock market, we don't have explicitly there's a guy called dealer, okay? We also have some people, what we call the hedge fund manager, investment banker, or smart investor. They are there to buy and sell, arbitrator. So you can imagine they have a similar role, okay? So these people actually they call the market maker, right? Because they are ready to buy and sell. And the dealer or the bank, you can imagine exchange market. Okay? You can imagine if you want to directly apply, you can imagine this is the bank who stand to buy US dollar or Hong Kong dollar or renminbi at the same time, right? And they provide liquidity, right? Because you can go there and buy and sell immediately, right? Different from the stock market, right? If you want to buy, you have to wait until your order being satisfied, unless you pay more premium, right? Otherwise, you have to wait until your order being matched, right? Even though you send market order, you may not, you can match, right? But if you send limit order, you may not, right? Even you send a market order, you need not be matched, right? It really depends on how the other side is going to sell or buy, right? So this dealer, actually the bank, right? They provide liquidity, right? You can go there and buy and sell immediately without waiting. So it's probably good, right? He facilitates the market, right? You don't have to wait. Okay. The problem of this is very common in stock market is everyone has different information, and some people are more informed than others. Okay. For example, insider or smart guy. Okay. And we imagine that the dealer is not very smart. Okay. But there are some people who are actually smart. Okay. And the problem is if you try to set certain thing, okay, no matter what you do, you got screwed up by some smart people. Okay, you attract some smart people to take advantage of your provision of liquidity, right? You're there to buy or sell. Okay. So later we will show you that this, to avoid this adverse selection, okay, the bid-ask spread is needed. Okay, he's not going to buy or sell at the exact same price. They have to set the wedge. The bid and ask will be different. To make sure that to reduce adverse selection. Okay, and in the other words, you look at the level 2 data, look at the limit order book, the best bid, the best offer, right? The best buy, best ask, and best bid. The difference, capture one of the thing, adverse selection. That means that if you see the bid and ask are so different, it means that the market is very divided on how the stock should be. Look at the foreign exchange market. You go to any foreign exchanger, look at which currency had highest bid-ask spread. So what currency have very low bid-ask spread? You can tell me. You guys are practitioner. How come you don't know, right? What? Look at Hong Kong. What? USD, right? Why? Because USD is, you can always go to the MA or go to Hong Kong Bank, right, to exchange for more or less the fixed rate, right? There's no adverse selection, right? No one have superior information, right? No matter how you think, right? At least for the next coming 24 hours, okay? I cannot claim more than 24 hours. At least for the coming 6 months, right? I think that the peg will be there still, right? I cannot forecast more than 6 months, but suppose, right? But that will be. But other than that, you can see if you are going to look at the bank or foreign exchanger, right? Which currency you have the highest bid-ask spread? Is those currency that has expect a lot of fluctuation, right? Say suppose Hong Kong dollar versus the Russian ruble, right? So it's supposed to be very large. Right? One of things is adverse selection. Some people have superior information, some people not. So bid-ask spread is one of the very important is information asymmetry. So we'll prove it. Don't worry. We'll go to the model to show you why. I'm not going. Otherwise, this is not very useful if you go to the model. So make a setup. Okay. Setup is very simple. As I said, there are some people who are smart, some people not so smart. Okay. The smart guy is called informed. Not so smart is called liquidity. Not so smart simply means that they are smart, but they are trading not for the reason that they know something special. Maybe they just want to close it to buy other stock, or they have enough money and they want to sell it. Okay, rebalance. They're trading not because they know something. They trade because of other reason. Okay. And the dealer is risk neutral to make our life easier. Okay, Just like the bank is big enough compared to the small trade, so that's why it's risk neutral. Right? As I said, right? If the bank is big enough, right? Every trade is very small, it can be risk neutral. Okay? And we will show you that there will be adverse selection if you only set one price. Then the bank will lose money. Okay? Which we will show you. Okay? And he will set two different prices to balance this. Okay? And balance two things. Okay? He will gain from trading with dumb money, normal money. Okay? He will definitely lose from trading smart guys. Right? Smart money always win. Right? Because smart money know where to go. Right? But if you trade with normal money, then it's okay. You gain some money from them. And the gain is cover the loss. Okay? If they set the same price, he always lose. Okay? We will see the model, but that's the setup. We will see more clearly the model. Don't worry. Now, we will make a lot of assumptions to make our life easier. Okay? Otherwise, the model is not tradable. So we assume what we call, this is called the sequential trade model, which means that the bank is standing here. Okay? People come one by one. Okay? When people come in, he only trade one shares. Simplicity, right? You can allow trade more, but just make a simple model, just trade one shares. Whether he buy or sell, according to the price I post. Okay? I'm the bank, I post I want to buy or sell. Okay? This particular stock or US dollar, right? Whatever. Okay? And you can imagine that from the bank perspective, okay? Or the world will decide the order, people arrival is a random, okay? So there's no control. The guy who actually come in immediately next second, whether he is a smart money or not so smart money, is random from the bank perspective. Okay? Bank doesn't, it's not clustering, say, there will be a lot of smart money comes in and then followed by a lot of not so smart, but each time is independent. Okay? So it's okay, it's not something terrible assumption. I think that's fine. Make our life easier. Okay? Because by doing so, we just need to only care about one-to-one. Right? We don't care about very complicated sequence of trading. Okay? Now we make our life easy. Okay? We think about stock. Okay? But foreign exchange the same thing. Right? The stock is either high value or low value. Okay? High value will be VH, low value will be VL. The probability will be 1 minus delta for the high. The delta will be low. You can later think delta is 0.5, equally likely, but need not be. But just to make, later we make some number there, make our life easier. Okay? And for the market maker, okay, for the bank, he will think mu of people are smart. 1 minus mu are not so smart. Okay? And this mu exactly captures the information asymmetry. Right? If the market is not very efficient, right, there will be a lot of mu there, right? A lot of people who have special information. Otherwise, it will be 1 minus mu. Okay? Now, in this model, our life is very simple. Okay? So, liquidity means that these people are normal money, not so smart. They buy and sell equally likely. So it means that half of people want to buy, half want to sell. Okay? They don't have any preference. Some people want to buy, some want to sell. Normal money. Okay? You can change this number, doesn't really matter, but just make our life easy. Okay? Equal likely they will buy or sell from the bank perspective, the broker dealer perspective. Okay? And this smart money, okay? The nature will tell them whether it's a good or bad. Okay? They know because they're smart, right? They know whether it's VH or VL. Okay? Of course, if they see good news, they will buy. Right? If they see bad news, they will sell. They know exactly. If you don't know, then they just equally buy or sell. Okay? If you know, then they would be good news to buy, bad news to sell. Now, let's see this diagram. I think that would be another break. So, So the very beginning, the news, so the nature would decide whether it's good or bad. Right? Every day, right? When the market before open, okay, there will be people would have some information there, whether the stock is going to go up or go down, right? It's good or bad at the end, okay? And then once they decided, the trading start, okay? The first guy would come, he may be an informed guy or an uninformed guy, right? He may be smart or not so smart, okay? If smart, then he always buy, right? If it's not smart, then he will be there. Okay? Of course, the bank doesn't know whether actually it's a good or actually bad, right? He can't tell where he is, right? But he knows if he's the bad news, those the smart money will always sell. Normal guy will just equally divide it between buy or sell. So that is the model, okay? And the bank will keep learning, right? Because people keep coming over the day, okay? So that would be the model. Is that clear? The model is there's a bank or the dealer, okay? He stands there to trade, okay? Let me finish this small slide, then we'll take a break. So the dealer have to set two prices, maybe equal or different. A with the price is asked, B with the bid, right? Ask with the price that the dealer, okay, want to sell to you, right? The bid the price, okay, they will take it away from you, okay? And as we said, if the stock is going to be good, the smart money would buy, otherwise would sell, right? And the people was uninformed equally, okay? And the dealer cannot differentiate which is smart, not so smart, okay? And here is the most important equilibrium condition, okay? We assume the dealer, there are multiple dealers. Imagine foreign exchange market, right? You have Hong Kong Bank, you have Hang Seng, you have many banks, and foreign exchange can easily buy or sell anywhere. You can assume perfect competition, right? In the sense that the ask price will be equal to how much you think the value of the security is given the buy order comes in. Okay? Because when someone buy comes in, I would change my idea. I would base update, right? Why a base update? Because remember, look at here. Go back to here. If I am here, we have more buy than sell. If I'm here, I sell more than buy. So if I buy, more likely to be here than here. Am I right? Right? Good news, with more buy. Bad news, you have less buy. So if I see a buy come in, I should infer it's more likely to be good news. Right? Then this is base updating, right? Okay, I can calculate if actually I see the buy, what should I think the value of the stock is? That would ask price. What is the bid price? Is the sell comes in, I update my belief, right? It's more likely to bad news, right? So this is lower. So that's why ask price must be higher than the bid, right? Because ask price is you see the buy, that should be the value, right? The bid is the thing is you suppose you see a sell, what you think is more likely to be negative news, right? So this expectation will be you see the buy, how likely is low times low, right? It's the same, right? The same as what we learned expectation, right? But now is conditional on the buy, right? Because you actually see the buy, right? Because it means no regret, right? Because someone comes in, what price you should sell to that guy is if actually he comes in, I change my thinking, this is the value of the stock, I sell the same price, right? Same for the bid. Okay? So after that, we'll try to, now we actually see the first thing is, very likely, we don't prove it yet, but ask price must bigger than bid. Okay? And we'll see how this number changes according over time, how this thing being determined. Okay? We'll talk about this at break. It's a break, and then we'll talk about some base rule and then tell you how to operationalize this. 但係最主要個 model 就係話你嗰個 bank 喺嗰個 FINA，即係佢隨時個 price 買賣價，咁咗個市場都有流動性啊嘛。流動性可以變化，大家都冇人反對。咁但係呢個成本好似係孭㗎嘛。咁點樣孭咧？就係即係個自我價差價。你個 model 要飛㗎嘛，你要賺錢㗎嘛，你攞先包期份攞3分。咁我咪見到好多人買咁嘅，即係學到咧，即係呢樣嘢你可以做 app 㗎嘛。我呢度冇講啊，但係自己佢個 model 係將佢飛㗎，係咁賣，自己你見到好多人買咁咪會 convert 之後，最後個 model 表現，最後到 convert 數，個 model 最後到 convert 數，我哋有個 mark 個 price，而家先到 convert 數嗰度。係不斷咁 trade 嘅話，就係finance time 就呢啲。但我冇搞到咁複雜啦，呢個你都話係啱，點會搞呢個 learning 嘅問題？你冇講緊點樣而家一路咁樣點樣咯？因為liquidity係比對於所有人都可以買上去嘅，因為個 market 咧其實嗰啲咪好難做，就所有嘅 convenience。B.B.A 都係有人俾，但係你就係樓，你邊個俾我冇 B.B.A 喎？冇人提呢樣嘢，咪要買賣好貴咗。樓你就冇 B.B.A 冇人提供條件買賣，所以賣咗。嚇？其實嗰度都係等有人買㗎嘛，佢哋產生冇人去收㗎嘛。佢當鋪都當鋪咧，有時佢就係嗰個當鋪你當一嚿嘢佢借錢，咁個市場大方向。但係你嗰啲係冇呢個買賣隨時買賣嘅，咁咪諗咯，等到有人嘅，咪做，咁咪成本高咯。後尾大後尾佢有個 investment， 你嗰間書個係冇佢哋咁諗咯，都有為主，我正想做嘅嘢，即係你俾貴啲咯，即係佢嗰陣時所謂我係不知嘅，你佢冇咁買翻嚟，但係呢個成本就係買呢個低嘅標準，而家就咧都飛埋去。佢呢啲 model 都係可以，好多人做 level 都呢啲。即係話我啲 model 嘛，咁即係講有一集邊啲係賣幾多錢，啲人賣幾多錢，賣出嚟。呢個係喺呢個卷就可以睇到嘢㗎嘛。你部手機出嚟睇下，你買嗰時見到賣入價，賣出價成站排隊嘅，喺呢個排隊呢個應該睇到嘅，所以係做嘢。睇啲啦，有計到啲嘢㗎嘛。可以計到有幾多個 market 幾雙幾人雙，咁就可以做嗰啲人，可以計到啲嘢。有人計嗰啲全部都有嘢計㗎。我講呢啲全部都唔係淨係雙話，真係有人做嘅。所以你覺得係我係喺度浪費大家時間嘅，最緊都係我係唔好誤會我誤會你。係考一件事，但係我係教啲都係有 apply 嘅，唔係真係有人計啲嘢。有人計喎，如果你對翻你個 data 有啲咩 measure？ 係啊，就話合身大一埋，或者一個人編咗個跟住編嘅，冇辦法。係啊。會乜都係。 翻嚟嚟到大概波斯灣啲波斯灣航海一定係有嚟嘅，因為如果打仗乜係全個世界嘅 trade 㗎嘛。你做 professional 咧，就可以。所以點解美國佬會有咁多人？點解咁多年打全世界嗰粒航空母艦？因為佢美國好多組都係國際嘅，所以好願意提供俾佢，所以咁樣。歐洲嗰成都幾咁，即係跟住你都係你到提供俾佢嗰個。好啦，之前你咧係即係 exchange 嘅 trade off 啫嘛。你咁航母艦得啦，你話事算啦，算唔緊要，讓你話事。台灣航母艦咧，我100%俾你做大佬。咁啊，自由翻世界咯，係啊，呢個就一個係自由主義，一個係民主嗰個。animal 係一個大自然嘅適者生存，而家會跳落嚟。咁大家都 waste money on building weapons。咁最尾打去咗張券啊！最多人真係唔錢，有少少餘口。揸車之外，打出嚟冇啲炸彈嗰啲嘢。你冇咗炸彈就食咗飯㗎嘛，都係飯。而家美國打，而家美國空場係冇人打仗㗎嘛，所以個 resource 都對晒你嘅 production。或者做 weapon 因為冇咗，你有啊都係打嘅，只不過就打仗。係出咗大咧，你搞我咁大開生意，只不過好細，相對嚟講細到，即係你嘛，但係對於數三十條咁。之後
係。So let me explain a bit again. So there is a price competition or purchase competition, makes that the ask price will be exactly the same as how the bank or the dealer would think the value of stock would be if actually the buy comes in. That means there's no regret, right? As long as it means that if the bank, the dealer, trying to sell at A, right, he's not gaining or losing, right, at that point, same as the buy, okay? And this conditional expectation means that under the buy, he thinks that it's, of course, less likely is low value, right, more likely high value, right, and they just look at average of this. Don't worry, I'll give you the numbers that you can calculate, then you will see much easier. Okay, so don't worry. Number will be there, then you will feel happier. It's a little bit abstract, might be. So before we do that, let's very quickly review probability theory. There's some formula there. Okay, so this is what we call probability A given B. So if no B had happened, what is probability A would happen? Okay, so let's make the example here. Okay,
may be easier to think. Suppose Roy died. You have 6 numbers. Okay? What is probability of 1? Will be 1/6. Right? And suppose conditional, I tell you that the row of die is an odd number. Okay? What is the probability of getting 1? 1/3. Why? Because now only 3 possible cases out of 1, right? But if it's same as you can calculate how likely that it's a fraction. The numerator is A intersect B, is A and B, means that it's equal to 1 and odd number, which is 1/6. And the denominator is probability of odd number, which is 1/2, so it's still a 1/3. Is that clear? Okay, so that is how you do the definition. So there's nothing to understand. This is how you define, right? So how you define, right? Just basically counting, right? And A and B is same as you condition on B times B or A on A. Just look at the multiplication of the first, okay? And that is what we call law of total probability. Is probability A is A together B, A together with no B, right? It's B complement with not B there, okay? And you can apply this property there. This is what do we have? Okay, don't worry. We will look at the graph. You will see this formula will be very easy. Okay, the difficult is look at the formula may be very difficult, but look at the graph will be easier. Okay, hopefully that will be just definition here. Okay, and if you still remember anything from your probability class, if you learn, this is the most important one, the Bayes rule. Right? The Bayes rule is how you update your belief. Right? If you learn machine learning, one of the learning techniques called Bayes learning, Bayesian learning is this one. Okay? And this looks very complicated. Probably, I doubt you remember, but later I'll show the graph. Hopefully they're easier. Okay? There's a formula. Just apply that. But let me later tell you how we do that. Okay? Although it looks crazy, okay? Don't worry. We will try to give you the idea. So maybe I draw a graph. So what the Bayes rule means is the following. Okay? So suppose the tree is either A happened or A didn't happen, right? A or A complement, right? And after A is either B happen or B does not, right? B happen or B does not, right? C means it doesn't happen, right? So let me see the formula there. I use A, right? Oh, sorry. Let me replace A and B because I use the notation a little bit reverse. Maybe B first. But same, I mean, I just do it because I try to, okay. So now the question is, I look at the formula I have is probability that B happen, suppose I say A, right? So remember B or BC may be high. Maybe you can think this is a good news, right, or bad news, right? And this is someone who buy or someone who sell, right? Someone who buy and someone who sell, right? This is the formula there, right? So if I see A, I see someone buy, how likely this is good news, right? So that's a question, right? So here you can see if there's A, or there's a buy happen here, means that only this is possible and this is possible, right? Only the first and the third branches are related. No, it's given A had happened. A had happened. You know A is true. Only the relevant thing is the red one. Right? I tell you that A had happened. Someone had buy. Right? For you, the only relevant is just only 2, 3. And out of which the probability B, that means that maybe I use another color. The base rule would ask, what's this probability? Will be just red, will be just red over red plus pink. Why? Now the only relevant is red and pink, right? Only red and pink relevant. How likely is the red one? It's red over red plus pink. That's the base rule, right? Because you know now buy has happened, right? So only relevant is the first and the third branches. And how likely is the good news? It's just the probability good news, and you buy over good news and buy, and bad news and buy. Is that clear? So this is what we call the base rule. I mean, you learned that in undergrad anyway, but probably you forget, but that's how you do it. Okay? Let me repeat. Red is what? Red is good news, buy, right? And good news, buy, bad news, buy. Then it's the probability that is actually good news, right? Given you buy. Fair enough? You want a, so red is good news, buy, good news and buy, right? And this is bad news and buy. This is very simple. If bad news is very unlikely to be buy, if this is small, that means whenever you see buy, it must be a good news. Is that clear? Is that okay? So this formula is not invented by me. It's you learn undergrad. But I teach undergrad first year, so this is what I taught there. So nothing very deep there, right? Because now you know it's going to be A is happen. So only the first and the third branch matters. And you ask whether actually is the upper row. Upper row is over the sum of the 2 row relevant. Right? Is that clear? Don't worry, don't worry. We will go to the number, then you will be, hopefully will be less confusing. Okay? Let's look at numbers. Okay? Let's look at the stock is either 0 or 1. The stock is valuable $1 or nothing. Okay? And initially, it's equally likely to be good or bad. Okay? This will change according to the trade. Okay? Initially is 1/2. Okay? Eventually, after many trades, the market will learn what's going on there. You take time because people keep trading, right? Because you will see good news where more buy, and updating will at least the market will know eventually. Okay? If it's 0, eventually you'll learn. Okay? But that's not a concern. We just want to show you the result. So make our life easier, the equal number of smart money and normal money, okay, equally likely, okay? So that's why with PI is, and PU equal to 1/2, okay? And equally likely there's a good news or bad news, okay? So we said if the guy is a smart money, right? If he knows it doesn't worth any money, he will sell. Assume short sale is possible, or he has the stock he can sell, right? And if he knows it's a good news, smart, then he must buy, right? If it's a bad news, he will never buy. If good news, smart, never sell. Fair enough? Now go down. As long as he's not so smart, it's you, uninformed, okay? No matter is actually is the bad or actually good, worth 0 or worth 1, equally likely. Okay? Smart money always do the smart thing. Normal money, just random. Okay? It's either 0 or 1. Okay? And everything is symmetric 1/2. Is that clear? I hope the model is simple enough. Now, once you have that, you have this here, right? So everything changed to number. I hope that makes life easier to see. Okay? Now, we are trying to show you how we can calculate the bid-ask spread. Okay? First, there are 4 steps. We'll do one by one. Okay? The first step have to tell, given that is a bad news or good news, how likely someone come to sell. Okay, that is what they're doing. So the first one, right, is look at if the stock is valueless, how likely that we have sell. If it is valuable, how many people will come to sell, right? If valuable, how many come to buy? Valuable come to buy. Okay, so this is a 4 number. It's scenario analysis, right? Suppose the stock is valuable, how likely that he's come to sell or to buy? Okay, the first thing. The second thing is, okay, if that's the case, I want to see how many buy or sell will actually come. Okay, how many people come to sell, how many to buy? Okay, without knowing actually what's going on. Okay, and then next, okay, I want to see if it is a sale come in, how likely it's worth nothing, how likely worth a lot. Basically flipping the first step. The first step is flip, and that's rely on Bayes rule. Okay. Bayes rule does a flip. Okay, and the ask price, okay, is to evaluate the value of stock based on the first step. Okay? So don't worry, we'll go one by one, you understand. So it's not something high technology, but you will go one by one, and you understand why the bid-ask spread, how it comes in. So where's So we show the graph. Now looks a little bit crazy, but let's see this, okay? If V is 0, how likely that you will sell? So this one looks like crazy, but let's look at the crazy thing here. Go back to here. Suppose it's a bad news. Where are we? We are here. Suppose we are bad news. We are here. Right? So ask ourselves, how likely that we will see a sale? Right? Is it the question? Right? I buy, sell, right? Sell is this and this, right? It is actually, we're here is actually this guy and this guy. And what? How do you get the probability here? This multiplied by this, right? And this multiplied by this, add up, right? 1/2 times 1 plus 1/2 times 1/2. right? Because there are two scenarios, right? Because sale can be coming from smart money or normal money, right? How likely is from smart money? 1/2. Normal money will be 1/4. Is that clear? So that's how you get the formula there, right? Although the math look crazy, but you don't have to look at the math. This is the graph. That's what it means. Is that okay? The second you ask, given this is, can I skip the scheme? Okay. Suppose now is a good news. How likely you're going to sell? Okay. Is that okay for this one? So now look at the case with the good news. It's actually value $1. How often you will see a sale? Right? Only sale is 0 is not there, it's this one. Right? So the only possible case is this particular guy. Right? So that's why it's 1/2 times 1/2 is 1/4. Right? Of course, 0 times 1/2 is also 5, but you don't need to worry. Right? You can do that, but it doesn't really matter. But if you want to be, then you want to highlight as well, but this is how you get 1/4 here. Right? Similarly, you can ask this question, if bad news, how likely is it a buy? Right? Will be this time this plus this time this. Right? That's give you the 1/4. Right? I hope that now it's clear how you get this number, 3/4 and 1/4, and 1/4 and 3/4. Is that okay? Just look at it and then add up. Is that okay for this one? Is that clear? If you assume that is a bad news, good news, you can calculate buy or sell. Okay? Now, the next question is to calculate how likely there's a sell or buy. Okay? And this, how to calculate that is go back to here. Now, we can calculate if it's here, how likely we have sell, right? And if here, how likely of sell as well, right? So we're asking at the beginning, how likely of sell, right? So it just from here all the way to here, right? It's here all the way, right? And that's how you get it, right? That's why it's 1/2 time, when you here get this 1/4, 1/2 times 3/4, right? So that's how you get this number there, right? Because asking how likely you will sell, right? Look at this, sell only here, here, and here, right? This is 0, doesn't really matter. You can include, but doesn't really matter, right? Just 1/2 times all the way, 1/2 times this, and 1/2 times that, right? That's calculate probability sale. Right. Is that clear? And of course, everything is symmetric. You should not be surprised this is actually 1/2 here. At the beginning, it's symmetric, at 1/2, right? Because in particular, at the beginning, the bank has no information. He believes this is 1/2, 1/2, right? The Bayesian learning, actually, this 1/2, 1/2 will change accordingly later. But at the beginning, there's no value there. It's 1/2. Now we finished 2 steps already. We calculate how likely is sell, how likely is buy, how likely is sell and buy given is good news or bad news. We know a lot, step 1 and step 2. So step 3 is actually reverse. Step 3 is go back. Suppose it's a sell. How likely that is actually low value. Okay, so go back to here. So the question is, suppose you sell, how likely is it bad news, right? So basically it's here. Suppose your sell is here, here, and here, right? Or maybe I use different color, right? Now it's I sell, right? So actually it's this branch, this branch, and this branch, right? I want to see, I want to know, right? If it's a sell, how likely that is worth 0, right? It's Bayes' rule. There are 3 relevant points here within the cell. The one with 0 is just only this 2. So it's green plus orange over green plus orange plus red. The Bayes' rule tells us. That's how we learn. Is that clear? So I want to know, given I saw a cell, okay? Now I saw a cell. Only relevant is this 3 branches, right? I want to know how likely that actually is a low value, right? Among 3 possibility, these 2 relate to low value, right? So it's these 2 over sum of these 2 over sum of the 3. That's how the Bayes' rule works, right? Is that clear? That's how the formula being applied. Right? That's how I apply the formula there. You can go back to here is how I apply. Right? Look at probability cell, it's just 3 lines there. Right? And this multiply is just that thing. Right? The 2 lines together is 3/4. Right? So it's very rational. Right? When you see a cell, it's more than half, that is a bad news. Actually 3/4. Right? If you don't know anything, it's equally likely. But now if you come a cell, you know it's 3/4 of time, it's actually bad news. Is that clear? So that means that if you see a cell, 1/4 is good news. Is that clear? Is that okay? Now we can reverse the process, actually symmetric, right? If buy, how likely is that? So go back to here, same idea. If it is good news, you see a buy, only relevant is this one, this one, this one, or this one, right? So when you buy, it's this red plus this orange and this green. Okay. If you see a buy, how likely is good news? If you see a buy, it's only red, orange, and green, right? And if this is good news, only can come from red and orange. So it's red plus orange over red, orange, green. That's a Bayes' rule, right? I hope that's okay. That's how we calculate that. Right? So that means that you have symmetrically 3/4 of time is V0. Right? I just plug in the number, but you can see the number same as what I mentioned in the thing, right? So now the last step is actually not very complicated, right? Because if you say buy, 3/4 of time is going to be $1. 1/4 of time is 0, right? So how much you should set, right? 1/4 of time is worth nothing. 3/4 of time is worth $1. To you, you're willing to sell at 3/4. Is that clear? So that will be what? Ask price. Okay. what will the bid price? Right? It's the value you sell. You know you saw a sale, 3/4 of time is a bad news. 1/4 time good news. That gives you a quarter. Right? So initially, if nothing happened, if no one have information, the stock would sell half, right? Equally 0, equally 1, right? But now, because of adverse selection, some people have more information. You have a wedge, right? Is you want to buy, you need to buy more than half. You can sell less than half. Okay. And so probably the next question you ask is, what happened after the first trade? Someone come in and buy, right? And the buy would occur that they will come in and buy at 3/4, right? So what happened to the model? The model actually will be the same, except this number changes, right? Because the market structure, people come in, doesn't change. Only changes how the market in aggregate thinks about whether good news and bad news would happen. Before, no one knows, no one trade, it's half and half. After the first trade, everyone in this market would notice 3/4 of them more likely to be good news. 1/4 will be bad news because the buy happened in the beginning. Okay? And you can do the same procedure as we do to update the bid-ask spread, right? Because everything we do is just based on how we draw the diagram and so on and so forth, right? Not going to go to detail here, but you can easily check, you can easily do the operation and update this based on this number, do all the thing, okay? Maybe a little bit quickly go over that. The first step will be the same, because the first step doesn't rely on the upper part of the graph, right? Just rely on lower part. So this unchanged. And the second part would change, right? Because the second part depends on how likely that you have sell or buy, right? The second part is asking how likely you sell or buy, right? So you're looking at how likely you got a sale would be something like this, right? This green thing plus this another green, right? Plus the other green, right? That gives you add the four thing up, give you how likely you sell, right? The other branch how you buy, and then you do the calculation, okay? I don't want to bother calculation because the same procedure would happen. So I want to show you the result at the end. It can look like this, okay? It will be, you start from half, okay? And you will be 3/4 and one half, 1/4. And the buy, there will be 9/10 and 1/2, okay? This is the same here, okay? And you can see, okay, the bid-ask spread actually in the beginning, how much is 1/2? How much is this, the second bid-ask spread? Is less than 1/2, right? So it keeps shrinking. So probably you ask, I don't prove, but you can show that in exponential learning, exponential time, it will approach very fast. You will converge, suppose it's good news, you will converge to 1 very quickly in exponential way. So initially the bid-ask spread is large, but it will shrink very fast. Okay? And the first thing is bid-ask spread is shrinking. Okay, so that is one thing. Okay, so you expect if there's no initially at the beginning of the market, right? When the market open every day, this information asymmetry largest, right? After one night over, right? Or after the weekend, right? But after that, there will be shrinks. Okay? Eventually, the market will learn what actually the price should be. And the bid-ask spread keeps shrinking. Okay? And you can do in very general because I focus on very special case, okay? But one thing you can see the bid-ask spread, okay? If you focus on equally likely is good or bad news, okay? In general, it can decompose in two parts. First part is how uncertainty the stock is, okay? Which is objective, how uncertainty people think about the fluctuation about a stock. The second part is mu is how many proportion of smart money, right? So, and that's why in some research, okay, or I mean, research means academic and practice, they look at when the market open, there's bid-ask spread, right? Because in Hong Kong, there's a bidding, initial bidding, right? After 9:30, then there will be trade, and the bid-ask spread there. The bid-ask spread there can inform us how information asymmetry the market is, right? Usually you can just assume certain things, but this is a good measure. That's why bid-ask spread is often in academic or in practice as a way to measure how efficient the market is, or how information asymmetry is, and how the SEC, not Hong Kong, but US one, they look at this to see whether there's insider trading, right? Because mu is the proportion of insider trading, right? Mu is people who actually know what's going on, right? The bid-ask spread is very large, then very clearly there's something happening. Okay. Now, before I end, go back to this particular slide, okay? You will see that in beginning, 3/4 and 1/4, the mid-ground is 1/2. That's right, no problem. Look at the day number 2. Half of 9/10 and 1/2 is not 3/4. What does that mean? It means that the usual assumption that the efficient price is average of bid and ask is wrong. So usually you would say, now I see the bid price is 10, the ask price is like 11, right? Then you would say the efficient price would be $10.50. It's wrong. Okay? It's wrong. The average is not the efficient price. Okay? It's not what the market thinks what should be. Okay? If you want to know what market think the price is, you should have to look at, you didn't know how market think whether it's going up or going down. Right? That is not, that the usual thing that people think is correct is wrong. Okay? But of course, economists doesn't know that until this model comes out. So this is one of the discovery of this model. Okay. So now go back to maybe give me 1 or 2 minutes. I finish this. So we learned last class is adverse selection, and this class public good. So we combine these two concepts to tell you that a dealer market, the dealer is providing public good, but there will be adverse selection. In order to solve this problem, the result is bid-ask spread. Okay, and bid-ask spread, go back other way around, is measuring information asymmetry. Right, so that's why when we apply this idea into our finance research or our investment research is we can look at bid-ask spread to infer how likely the market is asymmetric or not. Right, you can, because now these days we have level 2 data, right? We know the name of the book, we can calculate that as well. Of course, with that, there will be more complicated measurement. But with high frequency data, this thing can be easily calculated. Okay? And that's why beta spread is very important measure, right? Because before that, what we have is daily data. We have only open, close, high, low, volume. That's the 4 things we have usually, right? But now we have a lot of things, and beta spread is one of the things you can easily measure, because every time you can look at even level 1 data can do it, right? And in this model, you can see the smart money. Actually the bank is not making any money; it's making 0 profit. Okay, it's the smart money making money at the expense of normal money. Okay, the bank is not making any profit. Okay, he facilitates the thing, but he's not making anything. But just the smart guy I'm making at the expense of the poor, poorly informed. Okay, and as we said, the dealer, or you can think dealer is the market as well, the main market, right? The big market is actually keep learning, right? So that's the idea of what we call how. Probably you ask a question. We learned the topic 1 is demand and supply. How this price adjusts. This is the run of the process, right? There's a why the price adjusts accordingly. There's some profit opportunity. Some people are smarter than others, right? And they keep buying and move the market. Okay. And as I said, right, bid-ask price, the middle price is not efficient price or expected price. You have to look at how people think whether it's likely to go up or go down. You have to give you the right thing. Okay, and just 1 or 2 comment on further word. And some of you would say in this model it's very mechanical, right? In this model, people have information, just buy or sell, right? We don't answer the question if you're Warren Buffett, you don't buy big block. You don't tell people, right? So there's a model which I don't talk about that. It's called the continuum auction, which tells you that if people, smart people, can decide the quantity, right? How much they can buy. This model only buy 1 or 2, right? If they're smart, and then they can spread out their trade, right? They don't have to buy all at once, right? They can slowly collect, right? And you will see in that model, the smart people would just not trading until the very last moment, right? Or they would do it, and then before the market closed, they would just buy. That fit what you see. And in that type of model, one very useful thing is not just bid-ask spread, it's the depth. Okay, it's how much the bid and the ask, right? The quantity there, right? That would be one of the measures. But there's also used in actual practice, but I don't have time. We don't have time to cover because that model is a lot of math. So I don't even this you complain already. So I don't want to go into that as well. But at least give you some idea if you learn the market microstructure or more use the high frequency data. This is one of the first few models that you will learn. Okay. And as I said, I mean, some of you asked me during the break, is I going to ask the math? And I intend to ask, but from your response, then probably I shouldn't. But I don't know. Let's see. Yeah, I mean, anyway, if I ask probably multiple choice, part 1 question, but probably not going to make complicated if I ask. But anyway, so I will see you next week.